This is ECE Digital Signal Processing Homework 5, Problem 1. An LTI system with input x of n and output y of n has impulse response h of n equals start n minus 2 times start n minus 1 minus 3 data of n minus 3. Question A. Find a difference equation that represents the system. From the impulse response, we can get the z-transform of the h of n is 1 minus 2 times z to the power minus 1 minus 3 times z to the power minus 3. And h of z equals y of z over x of z. So the only possible answer is D, which is y of n equals x of n minus 2 times x of n minus 1 minus 3 times x of n minus 3. Problem B. Because from the clue, we know that for LTI system, we have input x of n equals cosine omega n times n to a system, which is h of e to the j omega equals a of omega times e to the j times phi of omega. We can always get the output, which is y of n equals a of omega n times cosine of omega n plus phi of omega 0. So here, you can get that h of e to the j omega equals 1 minus 2 times e to the minus j omega minus 3 times e to the minus 3 j omega. Which is, in the complex number, is the real part is 1 minus 2 times cosine omega minus 3 times cosine 3 omega, and the imaginary part is 2 times sine omega plus 3 times sine 3 omega. And from the question, we know that x of n is equals square root 2 times cosine of pi over 2 times n plus 1 over half. Thus, the omega 0 is pi over 2. So we can compute h of e to the j omega 0 equals 1 minus j, which is square root 2 times e to the minus j times pi over 4. So y of n equals square root 2 times square root 2 times cosine of pi over 2n plus pi over 4 minus pi over 4, which is 2 times cosine of pi over 2 times n. Here, pi over 2 is omega 0. So here's omega 0 times n plus here. This is the phi. Here is phi of omega 0. That is the solution to the question 1.